Evaluate limit of the function 3 plus h whole square minus 9 divided by h as h approaches 0. Now let's check what happens when we place h equals to 0 here. Do we get the limit? So if I do that, I get 3 plus 0 whole square minus 9 over 0, right? Which is 3 square, which is 9. 9 minus 9 over 0, and I get a form 0 over 0, right? So therefore, this is an indeterminate form, right? So whenever you substitute the limiting value, and if you get 0 over 0, then it is indeterminate form. 0 over 0 is not mathematically defined, but it gives you an idea that h equals to 0, that means h is a factor of both numerator and denominator. And if we can simplify this function, then we can cancel out h from numerator and denominator and then find the limiting value, right? So here the function is not defined as h approaches 0, so h is not equal to 0. But even if the function is not defined at a point, limit may exist, right? Because limit is the value which the function is approaching, right, from both the sides. It is not the value of function at that point. So limit exists or can exist even if the function is not defined at that point, right? Now let's try to check that. So we can simplify this expression, and so we'll write limit h approaches 0, and the function is 3 plus h whole square minus 9 over h. And now 3 plus h whole square can be expanded. So it is 3 square, which is 9, plus 2ab is 6h, plus h square minus 9 over h. So that gives us, in the numerator, 9 minus 9 is 0. So we get 6h plus h square over h. Now this could be written as limit h approaches 0, and we can take h common, right? So h common, so we get 6 plus h over h. Now as you can see, h and h cancels out, so we get limit h approaches 0 of 6 plus h, right? Now as we were expecting, so we did have a factor h in the numerator, which has been factored out, and it can be cancelled. So that means there is a hole as the function approaches 0, right? But when we approach that hole from both the sides, the value which we approach is 6, which we can find here by placing h equals to 0, we get 6, and that is the answer. So limit of this function as h approaches 0 is 6. So that is our answer. Okay, I hope you understand this technique of simplifying. So we'll have a couple of questions to practice this technique, and then we will move on to the next technique, which is rationalization. Thank you and all the best.